I'm Anil Kumar, and in this list of videos on finding limits, I'll discuss how to find limit when x approaches infinity. I've discussed this topic also under the heading of horizontal asymptotes. So, horizontal asymptotes is if x is approaching large negative or positive value, which we write negative infinity or positive infinity, does the function approach a value, a real value? If it does, then that becomes the horizontal asymptote for the function, right? Now let us see how to use limits to find horizontal asymptotes. Perfect. The question here is limit x approaches infinity for the function 2x squared minus x plus 1 divided by 3x squared minus 5. Let me give you the answer first and then we'll work out. Whenever the degree of numerator and degree of denominator is same, then the limit will be ratio of their leading coefficients, which is 2 and 3 here. So we expect answer of 2 over 3. Now this is slightly different. Here the degree of denominator is higher. Whenever degree of denominator is higher, like in this case, numerator degree is 2, denominator is 3, x cubed. In that case, the limit will be 0, right? Horizontal asymptote will be y equals to 0, and in this case, y equals to 2 over 3. So you could actually write down the answer for such questions very easily, but now let's learn the technique, right? So we could write this limit as limit x approaches infinity. We have the function 2x squared minus x plus 1. So what I will do here is that I will take x squared common, right? So if I take x squared common from the numerator, I'm left with 2 minus x divided by x squared will be giving me 1 over x plus 1 over x squared. Is it okay? In the denominator, I'll take x squared common again. I get 3 minus 5 over x squared. Perfect. Now we can cancel x squared and x squared. So we're left with 2 minus 1 over x. So let me write this as limit x approaches infinity. We have 2 minus 1 over x plus 1 over x squared divided by 3 minus 5 over x squared. Now if I substitute x as infinite, very large number, 1 over x will be 0, right? So I can write this as 2 minus 0, even that will be 0, plus 0, divided by 3 minus 0. Do you see that? So what do you get? You get 2 over 3. Correct? Ratio of their leading coefficients, right? If this was A, this was B, the answer was A over B. Is that clear to you, right? So it is a very general formula, easy to remember, and it really works for multiple choice questions, right? You like it. Let's do the next one. We'll follow the same technique. So we'll write this as equal to limit x approaches infinity. We'll take x squared common, right? So x squared. So you get 1 minus 1 over x plus 1 over x squared, right? Divided by, let's take x squared common. So you could take x cubed also common, right? Anyway, so anything, let's take x squared common. In that case, we get 3x minus 1 over x squared, right? Now cancelling x squares leads to what? Limit x approaches infinity. We have 1 minus 1 over x plus 1 over x squared divided by 3x minus 1 over x squared. Now remember, if x is very large, 1 over x is 0, this is also 0, that is also 0. So we can say that this is equals to limit x approaches infinity for 1 over 3x, right? 3x. Since x is very large, If I substitute large quantity here, then I get 1 over divided by a large number, it is equals to 0, right? So whenever the degree of denominator is higher, we'll have some x term here, and when that leads to a high number, any number divided by that number, large number, will give us 0. Now if this was minus infinity, even then the answer was same, correct? In this particular case, perfect. So we get the same answer. So remember, if the degree of denominator is higher, then the limit will be 0 when x approaches infinity or minus infinity, both cases for such rational functions. Is it okay? Now we also call this as, so that is just an addition information. We say horizontal asymptote is y equals to 0. In this case, horizontal asymptote is y equals to 2 over 3, right? That may be of interest for some students, so that is an additional information. I'm Anil Kumar. You can always share and subscribe to my videos. Feel free to post your questions, and if you like, that would be wonderful. Thank you and all the best.